In order to calibrate pipettes, you need several things. The first thing you need is a pipette calibration SOP. This is ours. Also, you need a form to write your documentation, your results in. This is the way ours look. This is transferred to an Excel file that automatically calculates our values. You need an analytical balance. Our analytical balance has a volumetric flask inside of it. You also need a beaker with a NIST calibrated thermometer. You need the actual pipette itself, and then you need pipette tips. Lastly, you're going to need some gloves to handle all of this.
This is the pipette we're going to be calibrating today. The lowest setting on here is 100 microliters, noted by the 100 right here, and then the highest setting is 1,000 microliters. As you can see, it goes all the way up to 1,000. So those are two of the settings we'll be doing measurements on. We'll also be doing 500 microliters, which is right in the middle of this, just so we can get a good, accurate reading on how well this pipette is calibrated. And there's also a serial number on here. It's going to be right here. You can see it says 256655. That's the serial number you'll be recording, just so we can track which pipettes we're doing calibrations on.
Now we're going to discuss how you adjust the volume you'll be dispensing with the pipetter. With the Eppendorfs, there's a button on the side that you need to press. Then you can rotate the knob to the appropriate volume. In this case, we're going to go from 963 to 1,000 microliters. Now we're at 1,000 microliters. This will be the volume that is dispensed. After you dial in your number, you release the knob and it locks it in.
In order to put a pipette tip on, we have our pipetter that we're going to be calibrating, and all you do is you just take your pipette, find the tip that you want, and just push it in pretty hard. Make sure that it's not going to fall off, and here you go. You have your tip on your pipetter. There are two stops on a pipette, so you can feel it. There's the first stop, and then there's a little bit further, which is the second stop. I'll do that again. So there's the first stop and the second stop. This is a large volume, so you'll be able to actually see how the pipette goes down for the first stop, and then there's actually a bigger jump. But for a smaller volume, you actually won't be able to see it as much. It'll just be a feeling that you have when you're actually getting the volume. So to be able to get our water sample, we're going to go down to the first stop, put our pipette in here, and take some volume. So that was the first stop in order to get the volume. In order to dispense your volume, you're going to go down to the second stop. You can hear a little click. Different pipetters have different ways on getting the tip off of the pipetter. So on this particular one, we were talking about the first stop and the second stop, but if you go a little bit further and kind of just push all the way down, it releases the pipette tip. Now, on this model, there's actually a different mechanism altogether for releasing it. So this is the one that we were using to get the volume, but to release it, there's this knob right here. Put it in here and push it right down, and it takes the pipette tip off. When you're getting your volume, sometimes some water can be stuck to the outside of the pipetter, and this can actually throw off our reading. So when this happens, all we do is we take a chem wipe and wipe the tip off, and now we're good to go. Also, sometimes when you're getting the volume, you'll see a little bubble in the tip. You see how the water doesn't go all the way down to the tip. And this is going to also throw off your volume. So when this happens, we just need to take all of the water out of the pipette tip and start over again. So after we've dispensed the water out of the pipette, sometimes there's a little bit left over, and this is volume that's actually still left in here. So if we try to get another like 500 microliters, it's actually going to be a little bit more than 500 microliters as this water is still stuck in here. So when this happens, we'll just take a new tip. Before we start actually taking some measurements, we're going to fill out our form first. basic things that you'll need is the date, who's doing the calibration, what location the pipetter came from, the model number, which is located on the pipetter. For example, we're doing the Eppendorf reference. The serial number, which is on the top right near the knob where you change the volume you're showing. The volume range of the pipette, which is also on the knob. This one is 100 to 1000 microliters. I also put a conversion up here so we know 1 mil is 1000 microliters. For this particular form, the test volume needs to be in milliliters, so I already went ahead and converted it. So the 100 microliters is going to be 0.1 milliliters and so forth. This one's going to be 0.5 milliliters, this one is 1 milliliter, which is 1000 microliters. So we're starting out with our calibrated balance, and the first thing we're going to do is put our volumetric flask in here. So we open it up and put it in like this and close it. As you can see, there's a weight that's showing on here. We actually want to zero this and make it 0, so it will start weighing the water inside and we don't want the volume of the flask to show. So we'll 0 this and it will show as 0 weight, and that's where we need to start from. So we're going to take our first volume, which is 100 microliters, and we're going to put it in our volumetric flask. So put it in here, close it, and we will record this value here, which is 0.1039 grams, and we'll put that right over here in our first column. And we will be repeating this process either 5 times or 10 times depending on your SOP. After we've gotten our first value, we're going to re-zero or re-tare it so we're back to 0 grams so we can record our next volume. So let's take another 100 microliters. And this time it's 0.1068, so I'll go ahead and record that value. For the 100 microliter sample, I've actually done it 5 times. I have 5 replicates here. And now we're going to move on to the 500 microliters or half a mil. Now that we're doing 500 microliters, I have set the pipette to see 500 on the display. And now we're going to repeat taking the 5 replicates of the weight of the water. So we'll do the same thing that we did for the 100 microliters. So now that I've done the 0.5 mils 5 times, I'm going to move on to do the 1 mil. Now we're going to do our highest measurement on the pipette, which is 1000 microliters or 1 milliliter. We're going to go ahead and do and repeat it the same way we did for the 100 and 500 milliliters. Use the same pipette tip, that's fine. Go ahead and grab 1000 microliters. And we'll make sure that this is zeroed. And this should be very close to 1 gram. And it looks like it's 0.9925 grams. And we'll go ahead and repeat that same thing so all 5 of them are done. So now we're going to do the highest measurement of our pipette, which is 1000 microliters or 1 milliliter. And we're going to go ahead and grab the 1000 microliters. And make sure our scale is 0 to tare. And we'll go ahead and record this value, which is 0.9945 grams. So now that we have all the values that we need for our calibration, we are going to go ahead and take this to the computer and enter these values into Excel, and these will tell us whether or not our pipette has passed or failed its calibration.
Alright, so before we start calibrating, we want to make sure the pipette is clean, doesn't have any residue. We can open it up. There is no corrosion. looks clean. It's lubricated. But we can use isopropyl alcohol or ethanol to clean the pipette. Okay, so I'm gonna clean a little bit of the outside and inside before I start calibrating. There are some residue might need cleaning. This is 70% ethanol. Each pipette has instruction how to get clean. This Eppendorf have an instruction. Came with a box. It's got an oil. The box have an oil that lubricate the O-rings. Put it back together. Not that dirty. It's still. Do every 6 months I open it up and clean it up. Outside, clean outside. Wipe everything out, all the residue, all the germs, all the greases off. So it's ready. It's loose, so it's got enough lubrication on that O-ring. Otherwise, I have to lubricate more. Before calibration, I gotta see if need any adjustment. There is a knob for adjustment. I can, with a knob, I can turn it clockwise or the other way around to see, to get it to the calibration, that weight I needed. I usually like to 100% accuracy, but our spreadsheet allows 5% deviation. For some method, Clean Water Act use 2%. For macro, it's 2.5 or 3%. It depends your QA program, what percentage. The tighter the accuracy, the 1% is the most accurate one.